Chapter 9. Hot water boilers and fittings. Section 9.1. Hot water heating systems. In this section, we will learn about comparing both hot water and steam heating systems, natural circulation and forced circulation hot water systems. The objectives will be to compare the different types of heating systems and describe the functions. A hot water heating system produces hot water in a boiler and manages the circulation of the water to transfer heat to the point of use. Hot water heating systems have different characteristics and fittings than steam heating systems. They heat more consistently than steam heating, and the water will remain in the system at all times. A typical hot water heating system will operate around 170 to 180 degrees for the supply water, and about 150 to 160 degrees for the return water. Keep in mind, these numbers will vary considerably. Modern hot water systems will typically use a control scheme that resets the water set point based on changes in the outside air temperature. A natural circulation hot water heating system, or gravity feed system, is an older type of open, unpressurized heating system that circulates hot water using the difference in water density, weight per unit volume, between hot water supplied to heating units and cool water returned to the boiler. When water is heated, it increases in volume or expands, and the density will decrease. The excess water in the system will be routed to an expansion tank. During normal operation, the water level in an expansion tank varies as necessary to accommodate changes in water volume and to relieve pressure in the system. An expansion tank is located at the highest point in the system and has a vent line open to the atmosphere to release pressure. Excess water in the system is discharged through an overflow line. A forced circulation hot water heating system is a closed pressurized system that circulates hot water using a circulating pump. The low water fuel cutoff shuts the burner off in the event of a low water condition. The water is then routed through the flow control valve that opens and closes automatically to prevent natural circulation in the hot water heating system when the circulating pump is not operating. The circulating pump moves water from the boiler to the supply line. The supply line provides hot water to the heating units. Section 9.2. Hot water boilers. The learning objectives will be to list the operating pressures of modern hot water and steam boilers, explain how condensing boilers operate, and to summarize how electric and tankless boilers operate. Low-pressure boilers for steam or hot water are constructed in accordance with the American Society of Mechanical Engineers Boiler and Pressure Vessel Code, Section 9. This code covers steam boilers with operating pressures not exceeding 15 pounds per square inch and hot water boilers to be operated at pressures not exceeding 160 pounds per square inch. Temperatures should not exceed 250 degrees. High-pressure power boilers are designed and constructed according to the ASME code, Section 1. This covers steam boilers with pressures over 15 psi and hot water boilers with pressures over 160 psi, with operating temperatures over 250 degrees. The specifications for the operation of a boiler are stamped on the boiler shell and/or on a nameplate permanently mounted on the boiler. Many low-pressure hot water boilers used today are designed to operate at higher temperatures and pressures in order to meet the heating demands of large modern buildings. In this type of high-temperature, high-pressure hot water heating system, high-pressure water circulates from a large heating plant in a central location to buildings in remote locations. This provides the efficiency of using a common large heating plant for several buildings and industrial processes at remote locations. A condensing boiler is a hot water boiler fueled by gas or oil that achieves high efficiency by condensing the vapor in exhaust gases and recovering its latent heat of vaporization. This condensed vapor is removed from the system in liquid form by a drain line. A typical increase of efficiency can be as much as 10 to 12%. The effectiveness of the condensing process varies depending on the temperature of the water returning to the boiler, but it is always at least as efficient as a non-condensing boiler. A condensing boiler has an added heat exchanger, a secondary heat exchanger, to remove the required additional heat from the gases of combustion in order to allow the water vapor to condense. Because of the secondary heat exchanger, there is added resistance to the flow of the gases of combustion. This requires the use of a combustion fan to move the gases through the boiler to the outside. Each start sequence of a boiler wastes energy as the internal components are reheated. Therefore, a boiler has a higher efficiency when it operates longer without shutdowns. Most commercial boiler plants have 2 or more condensing boilers working in parallel. Each boiler is smaller than the maximum load required. If the first boiler cannot keep up with the heat loss, a second boiler picks up the extra load. If needed, more boilers can be added. This type of arrangement will more closely match a building's heating load for a larger part of the season because of fewer stop-start cycles. The condensate from the gases of combustion is slightly acidic. To avoid corrosion, the materials used to construct a boiler must be able to withstand this acidic condition. A condensate drain must be installed. A neutralizer can be added to the condensate to adjust the pH to an acceptable level. This is done by connecting a plastic container filled with alkaline marble or limestone chips to the drain pipe. An electric boiler is a boiler that uses electrical heating elements to heat water for residential or light commercial hot water heating systems. Electric boilers are classified by water volume and wattage. The heating element used in an electric boiler is an immersion resistance heater. Electric boilers may be more expensive to operate than fuel-fired boilers due to higher utility costs. However, they are effective in mild climates and where electric rates are more reasonable. The installation of electric boilers is simpler than fuel-fired boilers since no fuel piping or combustion gas venting is needed. A tankless boiler is a hot water boiler that heats water without the use of a tank. These boilers are becoming more popular, especially for residential use. Tankless boilers do not retain any water internally except for what is in the heat exchanger coil. Stored hot water cools off, wasting the energy used to heat it. One advantage of tankless boilers is that they do not waste this energy. In addition, they can have lower and cleaner emissions. When there is a demand for hot water, the water temperature sensor of a tankless boiler measures the water temperature and starts the heating process. The temperature sensor sends a signal to the control board. Depending on the calculated return and desired water temperatures, the gas flow or electric current into the burner assembly is modulated, and the electronic ignition sequence begins. Water is heated to the desired temperature as it circulates through the copper heat exchanger. When the temperature in the building space is adequate, the tankless boiler shuts down and remains in standby mode, pending the next call for heat. Section 9.3. Burners and igniters. We will list and describe the types of burners and igniters used in hot water boilers. In a combustion boiler, a burner supplies an air-fuel mixture to a burner face while metering the fuel in order to maintain a controlled firing rate. A tubular burner is a burner consisting of tubes with drilled holes that allow pressurized gas to escape into the furnace where the gas is burned. Tubular burners are mounted side by side in an array, with fuel and combustion air being fed to each burner. Each has a percentage of the total heating capacity. Tubular burners are typically used in residential boilers. A power burner is a burner with a forced air fan that brings air under pressure into close contact with the fuel. These burners can be very efficient because they can provide an optimal ratio of air and fuel. Some manufacturers classify this type of burner as a low-pressure gas burner if they burn natural gas only. A power burner is a single burner, and they are often used in larger residential and light commercial boilers. An igniter may be a standing flame that burns constantly, such as a pilot light, or a device that electrically charges a gas on each call for heat. There are two types, electric spark or hot surface igniter. An electric spark type is located near a burner, producing a spark to light the fuel in the burner. A hot surface type is located at a burner and uses a small piece of silicon nitride, which produces high temperatures when the electric current passes through it. Section 9.4 Hot Water Boiler Fittings. In this section, the learner will be able to describe hot water boiler fittings used for safe operation, measurement, and control. A relief valve is a boiler fitting that protects a hot water boiler from exceeding its maximum allowable working pressure. A relief valve is used for liquid service only and is rated in British thermal units relieved per hour. It opens in proportion to the amount of overpressure. This valve consists of an inlet, an outlet, a body, spring, and a tri-lever. Relief valves and safety valves will function in the same manner by opening to prevent an overpressure situation. Both a safety valve and a relief valve would be considered the most important fitting on a boiler. A relief valve should be located within 6 inches of the highest part of a boiler and should discharge to an open drain in the boiler room. The ASME Boiler and Pressure Vessel Code states that a tri-lever test should be performed on a relief valve every 30 days when the boiler is in operation or after any period of inactivity. The low water fuel cutoff for a hot water boiler is normally a manual reset type. This must be located on a boiler or on the associated piping system above the lowest permissible water level in the boiler. The lowest permissible water level is determined by the manufacturer. It will be located slightly above the highest heating surface. Remember, the heating surface is your boiler tubes. This level may be marked on the side of a hot water boiler. There are two types of low water fuel cutoffs used on hot water boilers, the float type and the probe type. One location for mounting a float type is in the hot water piping system above the boiler. Another location is on the boiler, similar to the low water fuel cutoff for a low pressure steam boiler. A probe type must be installed at or above the minimum safe water level established by the manufacturer. It may be installed directly in the boiler or in the piping out of the top of the boiler or header. It most commonly is mounted in the top of the boiler with the probe extending into the water space. A common design for a water flow proving switch involves a paddle located in the flow path of the water in the piping on the discharge side of the circulating pump. This type of switch is considered a fail-safe device. If the switch should fail, the contact will not be made, and the boiler will not be allowed to start. A pressure gauge is a boiler fitting that displays the amount of pressure inside a boiler. A compound gauge displays both vacuum and pressure. Pressure gauges allow an operator to monitor changes in pressure and maintain the equipment within a safe operating range. The gauge is connected to the highest part of the load side in a hot water boiler. In a steam boiler, it will be at the highest part of the steam space. The gauge must be positioned to allow for easy viewing. A compound gauge displays vacuum in inches of mercury and pressure in pounds per square inch. Pressure gauges are susceptible to pressure surges. To protect the gauges from surges, snubbers can be used. A snubber is a pipe coupling-like device that is designed to protect the gauge against unwanted pressure surges. It is designed with an orifice that slows the transmission of a surge so the gauge is not damaged. The smaller the orifice, the longer it takes the pressure to travel through the snubber. A temperature pressure gauge is a boiler fitting that displays both the pressure of the water in the boiler and the temperature of the water at the location of the gauge. This is often installed on the front or top of the boiler for easy viewing. The top scale will read the pressure of the water inside the boiler. This will be read in pounds per square inch. The bottom scale indicates the water temperature inside the boiler. An altitude pressure gauge is a boiler fitting that indicates when a hot water heating system is properly filled. When the black needle covers the red needle, the system is properly filled with water. The red needle can also be reset to conform to the water pressure in the system along with the compression tank by manually positioning the needle. Reading the altitude pressure gauges is a way to verify that the regulator is operating properly. If the hot water heating system has no pressure, indicating there is no water in the system, the boiler could be damaged. When the gauge shows a higher than normal reading, the regulator should be examined and any malfunctions corrected before turning the boiler on. An aquastat is a hot water boiler fitting that measures the water temperature in the boiler and controls the temperature by starting and stopping the burner. It controls the starting and stopping by sensing the temperature of the water in a hot water boiler only. The electrical circuit will be either energized or de-energized to turn the burner on or off, depending on temperature set points. A built-in temperature differential eliminates the possibility of the burner continuously starting and stopping, also known as hunting, at small temperature variations. A hot water reset control is a fitting that serves as a boiler water set point temperature control system with an outside air thermostat. The temperature set point can be raised or lowered based on the temperature at the remote location. The purpose of this control is to reduce energy use and improves system efficiency. While this control device is in operation, the temperature sensing device located outside the building sends temperature information to the master controller. Information relayed to the submaster controller, which compares the temperature outside the building to the temperature of the water circulating in the heating system. If the circulating water temperature is below the desired range, the submaster controller sends a signal to the burner to start, then controls the firing rate as necessary.